So I think we are ready for the live session. Wait a second, I'll be just starting with the graphs and also the BFS, right? So today's session will be graphs, breadth first search. So the today's agenda will be on breadth first search 31/01/2026. It's already 1 month. It's already 1 month actually, as 2026 has started. So anyone new to this live stream, please comment in the live chat. Yes, we'll be starting in a minute. Just yeah. So if anyone didn't attend the previous live session about the DFS algorithm, how did we solve the number of islands problem using the DFS, nothing but the depth first search algorithm, right? So I suggest you to go and check that live stream, or you can also go with any articles like that. So if you are new to this channel, let's go with what is a breadth first search. Like, just take a graph, one, two, and then three, four here, then five, and then a six. Now, after one, let me know in the live chat. After one, if I traverse the graph in breadth first search, what will be the next two elements? Please let me know in the live chat. After one, after traversing to the one, what will be the next two elements? You can just answer your uh, thoughts in the live chat. No one is gonna judge you. Yes. So after one, we will be having. Let me tell you, this bread will be nothing but a level order traversal. How does that level order traversal mean? Now, this is the first level, and then this is the second level, and then this is the third level. So, after one, I will go to the next level, two and three. Nothing but the connected elements are two and three. Two, then three. Now, when I got two, I will also push those elements which are adjacent to two in some data structure, right? So 4 and 5. Now after 3, I would go to 4 and then I would go to 5 and then the adjacent elements or the adjacent nodes of 3 are 6. Only 6, right? So 1, 2, 3, 4, 5 and then 6. This is just the breadth first search or the level order traversal, right? In a graph. But if you see, when I have this one, let me write it. When I have a node, I also need wait. I also need the adjacency element, the adjacent elements. Nothing but if I had 1 and the two elements which are adjacent to 1 are 2 and 3, if I just traverse them, now I will be at 3 and the adjacent element of 3 is 6. But I am missing those elements which are adjacent to 2, right? So what I can do is nothing but store the elements which aren't aren't traversed. Nothing but if I didn't see this element, or if I didn't see the adjacent elements of that node, I will just store in a data structure, right? Now, if you see, the first element will be always 1. Let's just say there is a data structure, something like this, 1, and the adjacent element of 1 is 2, and then 3. I want to traverse these elements after 1, so I'll just make that 2 and 3 in some data structure, right? So 1 is already traversed and I have 2 and then 3. Now for 2, I have 4 and 5. So I'll just cancel the 2 and I'll just push 4 and 5, right? Now for 3, I have the adjacent element 6. So when I saying for 3, I am having the adjacent elements as 6, just one node. I'll just cancel the 3, nothing but making it as a visited, and 6 will be pushed. This is not something like you can use in a stack. We will use this as a queue. Now, does 4 have any adjacent element which is not visited? There are no elements or no nodes which are adjacent to 4. It has 2, but 2 is already visited here, right? So 4 will be visited, and then 5, the same thing, and then 6, the same thing. So every time we will use we will use a queue to get the elements in graph, right? So we just use a queue to get the elements in the graph. Now, let's take the same example again. 1, 2, 3, 4, and then 5, and then a 6 here. So I'm just taking one first. First, in the queue, the first element I will push back is the root element or some element. There will be nothing like a root in a graph, there will be root in a tree, but one will be pushed back. Node 1 will be pushed back. Now in the queue, the first element is 1. What I will do is nothing but make a visited what do you say, visited array, which will be having 1, 2, 3, 4, 5, 6. I'm just taking one indexed array. Now 1, 2, 3, 4, 5, 6. 1. Is it visited? No. False, 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 and then false. Right. Now 1 is not visited. For the adjacent elements of 1 are 2 and 3, right? The 1 adjacent elements are 2 and 3. Now, when I get 1 as the first element in queue, just take that 1 and make it as true. That's it. Now, the adjacent elements of 1 are 2 and 3. Yes, 2 and 3. They both are false. What I'll do is, I'm saying that if they are only false, nothing but visited is false, nothing but it is not visited. So if it is not visited, first remove that one from the queue, and then the adjacent elements of 1 are 2 and 3, which are false, nothing but it is not visited. So 2 and 3 are pushed back into the queue. Now, I have 2 in the front of the queue. So, make the 2 as true and make it as remove from the queue. Now, the adjacent elements of 2 are 4 and 5. As I said, 4 and 5, they both are false. If you see, the adjacent element of 2 is also 1. 1 is also adjacent element of 2. Now, 2 will go to 1, check whether it is false, but it is true, right? So it doesn't push back into the queue. Now, it will check for 4. Is it false? Yes, it is false. So, for 4, it will check whether it is false. Yes, it is false. So, it will push back into the queue. Now, it has 5 also as an adjacent element. Now, for 5, it is false. So, it will push back into the queue. Now, the next element in the queue is 3. So go to 3 and make it as true and remove 3 from the queue. Now this 3 is having 1 and also 6 as the adjacent elements, right? It will go and check for 1. Is 1 false? No, it is not false. So it will skip 1. Now it will go to 6 again. Is 6 false? Yes, it is false. Nothing but it is not visited. So it will push back into the queue. Now this the next element which I'm gonna uh, search or traverse is 4. Now, as soon as I am traversing, the first thing I am doing is making it as true, right? Now, just remove the 4 from the queue. Now, what are the, what do you say, adjacent elements of 4? 2. There is only one adjacent element which is 2. 2. Is it true or false? If it is false, push that back into the queue. But it is not false, it is true. Nothing but it is already visited, no need to visit that again. So, then the next element in the queue is 5. Now, make that 5 as true first and remove that 5 from the queue and see the adjacent elements of 5. 2 is the adjacent element of 5 and look at 2. Is it false? If it is false, it means it is not visited. But it is true, that means it is visited. So, no need of pushing 2 back into the queue. Why? Because 2 is already visited, right? Now let us go to 6. The first thing which I need to make when I visit a node is make it as true. Visited of that node is made as true and remove that from the queue. And go for every adjacent element of that node. 3 is adjacent element if you see. 3 is adjacent to 6, right? Now, is 3 false for visited? Visited of 3, is it false? No, it is true. Nothing but 3 is already visited. You don't need to visit that again. So, that's how I'll get 1 and then 2, 3, 4, 5, 6 in the same way. But how can I write the algorithm for this? First thing, in the BFS, what I am doing first, in the BFS, I am having the root element is nothing but the first element or the, what do you say, 0. If I can say that as, wait a second, video capture device, display capture. Wait a second, let me search for number of islands. Yes, we have solved it 2 days before. We have solved this 2 days before. Yes, now we can see this. Okay, so 2 days we have before we were doing a live stream where we have solved this exact problem using depth first search. But now we'll be solving this in breadth first search algorithm. But let us see how can I write the breadth first search algorithm. First thing, what I am doing actually. So I am having once it is land and zeros means it is water. Written the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Imagine these cells as this is one, right? This and then this, right? So What if I am having cells like this? You cannot visit diagonally. If you see, this is also one, this is also one, nothing but land. Now, from this one, it is somewhere in the matrix. In the matrix, it is somewhere. I can visit four directions. What if I write it as one here, one again, here, one again, here, one again. That's how simple it is in a breadth first search. I am just visiting four of them simply. Now, how can I visit it? Let us write a breadth first search algorithm with the grid, with the given grid and with visited, nothing but the visited matrix, and also the node where I am starting with. Now we'll initialize a queue here, queue of node. Let us say that let me say this as in the queue, let's take a pair of int comma int is nothing but the row and also the column, right? So I have a queue. Now in this queue, queue dot push back, queue dot push back. Where is this node? Instead of node, let me say that as, let me say that as row and also the column, row and also the column, right? Now, while queue is not empty, queue dot empty, the first thing, go to the adjacent elements, right? What are the adjacent, you know, adjacent elements or nothing but the four directions, right? So for auto dir in dirs, new x is equal to row plus dir, new y is equal to column plus dir of 0. It is dir of, wait a second, dir of 0 and column plus dir of 1, if you see. Now, if new x is greater than or equal to 0 and new x is less than great, it is about the rows, right? Grid dot size, new x is nothing but the row, and new y is greater than or equal to 0 and new y is less than grid of 0 dot size, and also visited of new x and new y is equal to false. Let me tell you, if it is not visited, what we will be doing is just q dot pushback. It won't be a pushback, it will be push new x comma new y. I think for now it's clear. Instead of pushback, it will be just instead of pushback, it will be just push q dot push. Now we are having the every left and right. So here we'll take the first node as dir of 0, row and column, right? So we can just call that, I think so. Yeah, we can just call that. So now we can just say row is equal to q dot first of 0. Q dot first. Let me say q dot first Yeah, it would be q dot first dot first. Why? Because it is a pair, right? And column is equal to q dot front. Sorry, front. Q dot front dot first. Q dot front dot second. That's it for auto directions in direction. So the same algorithm we'll be using. So that's about today's live session. I think there will be more sessions every day, right? So it's about the consistency rather than the long or the duration. So thanks for attending this live session, everyone.